Imagine this. A mysterious rock hurtles through the vast emptiness of space, traveling for billions of years, untouched, unseen, carrying something that could change everything we know about life itself. And then, after an epic journey, it finds its way to Earth. But here's the real question. What if life as we know it didn't actually start here? What if the origins of life came from out there, from space itself? Ever wondered what's up there that we can't see? I'm Umbra, and I'll reveal it all. Keep watching. Well, recent discoveries have just thrown gasoline on the fire of one of the most mind-blowing scientific mysteries of all time. The Bennu asteroid, an ancient space rock that has been floating in the solar system for over 4.5 billion years, has just revealed something astonishing: the building blocks of life. Scientists have found organic molecules on this asteroid, the same fundamental ingredients that make up DNA, proteins, and life as we know it. Could it be that Earth was seeded with life from an asteroid like Bennu billions of years ago? Did life start in the deep, dark void of space and travel to Earth on a cosmic hitchhiker? And if so, what does that mean for us? Are we, in a sense, aliens? This isn't science fiction. This is real. And today, we are diving deep into one of the most extraordinary discoveries in space exploration. Buckle up, because this is going to change everything. To understand why Bennu is such a big deal, we need to go back a few years to when NASA launched a mission that would make history. It all started in 2016, when NASA sent out the OSIRIS-REx spacecraft on an ambitious mission: travel across space, rendezvous with an asteroid that had been orbiting the Sun for billions of years, collect a sample from its surface, and return it to Earth. This wasn't just any asteroid. Bennu was chosen because scientists believed it held pristine, unaltered material from the very formation of our solar system. Why is that important? Because if Bennu contained organic molecules, the carbon-based compounds that form the foundation of all life, it could provide crucial clues about how life began on Earth. For years, OSIRIS-REx studied Bennu, mapping its surface, analyzing its structure, and finally, in October 2020, it performed a daring maneuver. It swooped down, made contact with the asteroid, and in just a few seconds, collected a sample of dust and rock. That precious cargo, material older than the Earth itself, was then sealed up and sent on its long journey home. And on September 24, 2023, after traveling more than 200 million miles, the sample finally landed in the Utah desert. Scientists rushed to recover it, knowing they were about to uncover secrets that had been locked away for billions of years. They had no idea just how extraordinary those secrets would be. As soon as scientists opened the sample container, they were stunned. What they saw wasn't just a pile of ordinary space dust. This was something special. Inside, they found carbon-rich organic molecules, including amino acids, the essential components of proteins. Amino acids are the raw materials that form the basis of all living organisms. They are the Lego bricks of biology, combining in different ways to create proteins, which in turn build everything from muscles to enzymes to DNA itself. But here's the shocking part. These molecules didn't form on Earth. They formed in the cold, airless vacuum of space, long before our planet even existed. Scientists had theorized for years that amino acids might be common in space, but finding them on Bennu proves that life's ingredients don't need a planet to form. They can arise naturally in space and hitch a ride on asteroids and comets, crashing onto planets and potentially kickstarting life. This isn't the first time we found organic molecules on space rocks, but Bennu is special because it is one of the most ancient and well-preserved asteroids ever studied. It's like a time capsule from the birth of the solar system, giving us a direct glimpse into the chemistry that existed before Earth was even a thing. And here's where things get even crazier. The discovery on Bennu brings back a theory that has fascinated scientists for decades: panspermia. The idea of panspermia suggests that life, or at least the building blocks of life, may not have started on Earth at all. Instead, they could have been delivered here by asteroids, comets, or even interstellar dust. In other words, Earth didn't create life. Life came to Earth from space. Imagine this. Billions of years ago, in the chaotic, violent early solar system, asteroids like Bennu were crashing into young planets, including Earth. If these asteroids were carrying amino acids, sugars, and other organic compounds, they could have seeded Earth's ancient oceans with the ingredients necessary for life to begin. And once those ingredients were here, they could have combined in the right conditions, perhaps in warm tidal pools, deep-sea hydrothermal vents, or even icy comets impacting Earth, to form the first primitive life forms. Could this be how life started? Could every living thing on Earth, including you and me, trace its origins to molecules that formed in space and traveled here aboard an asteroid? And if that's the case, does that mean life could be everywhere in the universe? If asteroids like Bennu can carry the building blocks of life, then what's stopping life from emerging elsewhere in the universe? Think about it. If these organic molecules are common in space, and if planets all over the galaxy have been bombarded by asteroids for billions of years, then the odds of life forming somewhere else seem incredibly high. Some scientists believe that life may have started multiple times in different places in the universe, meaning that alien life might not just be possible, it might be inevitable. And if that's true, then Bennu isn't just a piece of rock. It's a messenger, a cosmic relic that tells us we may not be alone, that life isn't confined to Earth, that the universe may be teeming with living organisms, some like us, some wildly different. This is the kind of discovery that forces us to rethink everything about our place in the cosmos. Now that we have these samples from Bennu, the real work begins. Scientists will spend years analyzing them, looking for more clues about how life's ingredients formed in space and how they might have contributed to the origin of life on Earth. And this is just the beginning. Other missions, like NASA's Dragonfly mission to Titan and the upcoming sample return from Mars, will help us understand whether life ever existed elsewhere in our solar system. But for now, one thing is clear. The Bennu asteroid has given us a glimpse into our past, a window into how life may have begun, not just on Earth, but perhaps all across the universe. The revelation that Bennu contains organic molecules brings us to a profound and almost unsettling question. Are we, in some way, cosmic beings? If life's building blocks came from asteroids like Bennu, then that means every living thing on Earth, plants, animals, bacteria, and yes, even humans, are all descendants of cosmic chemistry that started billions of years ago, before Earth was even formed. This challenges the very way we look at ourselves. For centuries, we've thought of Earth as a unique cradle of life, a blue oasis in the vast, empty blackness of space. But what if life isn't unique to Earth at all? What if the same process that may have started life here has happened on countless other planets? What if asteroids, comets, and cosmic dust are constantly spreading the seeds of life across the universe? This concept isn't just a wild theory. It's something scientists are now seriously considering. The organic molecules found on Bennu could mean that life is not an accident, not a rare phenomenon confined to Earth, but a natural consequence of the universe itself. If that's true, then the search for extraterrestrial life is not just a curiosity, it's a necessity. Because somewhere out there, beyond our solar system, another planet might be teeming with life, following the same cosmic recipe that may have started life here. Bennu's sample is just the beginning. If organic molecules can be found on an asteroid floating in deep space, then what about places that have the conditions to support life? This discovery is pushing NASA, ESA, and other space agencies to look deeper into our solar system and beyond to find signs of extraterrestrial life. One of the most exciting upcoming missions is NASA's Dragonfly mission to Saturn's largest moon, Titan. Titan is unlike any other moon in our solar system. It has rivers, lakes, and even an atmosphere thick with organic molecules. Scientists believe that deep in Titan's subsurface there could be liquid water, a crucial ingredient for life as we know it. If complex organic molecules have already been detected there, could we find evidence of actual living organisms? Then there's Europa, a moon of Jupiter which has a vast subsurface ocean hidden beneath a thick layer of ice. NASA's upcoming Europa Clipper mission will get a closer look, analyzing the icy plumes that shoot out from cracks in the moon's surface. If life exists in Europa's oceans, perhaps in the form of microbial alien life, it could confirm that life is not exclusive to Earth, but thrives wherever conditions are right. And let's not forget about Mars. The Perseverance rover is currently exploring the Martian surface, collecting samples that will eventually be brought back to Earth in the next decade. Scientists suspect that ancient Mars may have had liquid water and an atmosphere, making it possible that microbial life once existed there. If even fossilized microbial life is discovered on Mars, it would be one of the greatest discoveries in human history. It would prove that life can emerge in multiple places in the same solar system. So, if the universe is filled with organic molecules and planets capable of supporting life, why haven't we found alien civilizations? This question, known as the Fermi paradox, has puzzled scientists for decades. If life is common, then where is everybody? Why haven't we detected signals or seen signs of extraterrestrial civilizations? One possibility is that microbial life, bacteria-like organisms, may be abundant across the universe, but intelligent life may be far rarer. Life may emerge easily, but evolving into complex, intelligent beings capable of building technology and sending signals into space could be an extremely rare event. Perhaps Earth is one of the few places where evolution led to advanced life forms. Another possibility is that alien civilizations exist but are simply too far away. The universe is unimaginably vast, and even if intelligent life exists, the distances between us may be too great for communication. Then there's a more unsettling theory, the Great Filter Hypothesis. This theory suggests that while life may be common, some kind of great challenge, prevents civilizations from surviving long enough to communicate. This could be anything from natural disasters to self-destruction, such as nuclear war or environmental collapse. If this hypothesis is correct, it means either we are one of the first civilizations to make it this far, or we are heading toward a challenge that very few civilizations have ever survived. Regardless of these possibilities, Bennu's discovery tells us one undeniable fact. Life's ingredients are everywhere, and if they are everywhere, then the universe is likely filled with planets that have followed a similar path to Earth. If Earth is not special, then the logical conclusion is that life, at least in microbial form, is likely widespread throughout the cosmos. So where does this leave us? The discovery on Bennu is not just about ancient organic molecules. It's about us. It's about our place in the universe, our origins, and our destiny. For the first time in human history, we are beginning to truly understand that we are not separate from the cosmos, we are part of it. Every atom in our bodies was forged in the heart of dying stars. The molecules that form our DNA may have been carried to Earth by ancient asteroids. Life itself may be a cosmic phenomenon stretching far beyond our tiny blue planet. This changes everything. It means that we are explorers by nature, driven by the same forces that created us. It means that our search for life beyond Earth is not just about curiosity, it's about finding our cosmic relatives. It also raises ethical and philosophical questions. If we discover alien life, even in microbial form, how should we approach it? Do we protect it? Do we study it? What if we find a world where life is just beginning? Do we interfere, or do we leave it untouched? And what if one day we make contact with intelligent life? How will we react? How will it change religion, politics, and society? Will it unite humanity or divide us further? We don't have the answers yet. But what we do know is this. The search for life beyond Earth is no longer a fantasy. It is a scientific reality, and Bennu is proof that the answers may be closer than we ever imagined. We are standing on the edge of a new era of discovery. The Bennu asteroid has given us a piece of the puzzle, a glimpse into the chemistry of the early solar system, and a clue that life's origins may not be limited to Earth. As we continue exploring the cosmos, searching for exoplanets, probing distant moons, and collecting more asteroid samples, we are inching closer to answering the greatest question of all. Are we alone? And if the answer is no, if life exists beyond Earth, then everything changes. It means we are part of something much bigger than ourselves. It means the universe is alive. It means we are not alone. Bennu has given us a message from the ancient past, a whisper from the universe itself. Now, it's up to us to listen. So, the next time you look up at the night sky, remember, somewhere out there, the same molecules that started life on Earth may be forming life on another world. And who knows, maybe one day we'll find it. Maybe one day it will find us.